me go over what you need to do for assignment 3. The assignment 3 cover the material for confidence interval and hypothesis testing. So the first problem, we have two types of tumor, type 1 and type 2. These are the sample information. Remember, when we have X bar S, that means it's sample information. If we have mu and sigma, that was population information. So for tumor 1, you have 20 sample. The average was 3.5. The standard deviation was 1.8. And for tumor 2 was 15 and 2.7 and 1.5 again for the standard deviation. So I ask you to calculate confidence interval. So for type 1, type 2, and also I ask you to calculate 99% confidence interval with difference between type 1 and type 2 population. So if you look at your handout, remember the confidence interval, basically you have your estimator times minus reliability coefficient times your standard error. So when you have the sample information, you would use the example you're going to use. This is the formula you're going to use for each type of tumor. So you have your S, you have your N, and you have your X bar. Then you have to find the T from T table. For 95%, you put your alpha is 0.05, you put that and find it from the T table. For example, there is an example in your handout. If you look at page 3, you see X bar was 71.5 plus minus. We find from the T table T at 15 and 0.95 was 1.753, for 12 was our standard deviation and 16, so you can find the confidence interval for the same way for each type. So for the difference between two confidence interval, then you have to use this formula. First, you're going to calculate the pool variance, which you're going to put the information. Remember, you have a standard deviation. You have to square to get the variance. Here, the same you do for sample 2. Basically, you calculate that, and using this formula, you can calculate the difference between two means. So this is an example. Again, you can look at it similar to that one. So you can find, first we find the pool variance by squaring 1.05 and 1.01, and then putting the information n and calculate the pool variance. Now it replaces in the formula. So for the problem 1, you have those two examples. You can look at it, and this is the interpretation if it's correct or not for part C. So problem 2, this is a survey we ask men and women about their smoking. Out of 430 men, 116 said they will smoke. Out of 380 women, 73 said they smoke. So I ask you, what is the proportion for a smoker for men? What is proportion for women? And then 95 confidence interval for a smoker for men, and 95% confidence proportion for a smoker. And that's the interpretation for confidence interval. And then the difference between proportion for men and women for a smoker. So again, this is the proportion you need to look at it. So if you look at your handout, again, going to proportion information. So the proportion, basically you have find your proportion plus minus the Z1 minus alpha. So you, from Z table, you find your reliability coefficient times the standard error, which is P hat times 1 minus P hat over square over N. You take a square root. So this is exactly another example you can look at it, how we calculate. We have 947 patient history of abuse. Out of 166 had history of abuse. That was the proportion of abuse. And for 95%, for 90%, Z1 minus alpha over 2 is 0.95, Z0.95 is 1.645. So you replace that information, you can get the, so 95%, or that was for 90, this is for 95% here. So you do the same for men smoker and woman, female smoker. And this is the difference between two proportion you can use. So basically the example in your page 12 handout can help you how to calculate. So that's you wanted to get. For problem 3, let's say researcher who study a chronic disease hospital outpatient, the following are information researcher find from 49 record. So your N is 49. The average outpatient visit per patient was 6, and the population standard deviation of 3. So, so here the average outpatient per visit was 6, and the population standard deviation was 3. So we know here this our sigma is 3. So, and here, what statistical test you would use when you know the population standard deviation? Remember, you have one sample here. Again, look, going back to look at your handout. So when you have one sample, and in terms of and you know your population variance or standard deviation, then you're using the Z test to see when population variance is known in page 15 your handout. So you would use the Z test to do the hypothesis testing. So, and here I ask you to calculate the Z statistics and then do the hypothesis testing. So basically, if you look at this example in your handout, page 15, it's similar to that. So you have to set up your hypothesis and find the Z statistics, which is using this formula, Z x bar minus mu over sigma over a square N. And then you would do hypothesis testing here. Here we are. We wanted to examine here. If we said we want to, can researcher conclude the population mean is greater than 5? Remember, this is you have the grader, so make sure you understand is one side or two side. The keyword is here. If it's directional, you consider as one side. So you're hypothesizing against 5, and your X bar here is 6. So basically you replace it and calculate the Z compared to Z from Z table. If your Z statistic is greater than Z table, you reject and you said you accept the alternative. So for problem 4, again, let's say researcher who study on daily caloric intake for certain adult population, a sample of your N is 36, the mean is 1900 with the sample standard deviation 100. So now here you have information about sample, not information about the population variance. So remember, when you have when you don't have the population variances unknown, then you use the T statistics. So, and there is an example in page 17, your handout. Again, you can use that and to calculate T statistic and do the hypothesis test. So this is question 5 is physical activity. We have 2 group, control and intervention. These are the information. So I ask you if the researcher wanted to examine there is a difference for physical activity between control and intervention, what statistical test you're going to use. Remember, here you do not have the population information and you have 2 samples. So I ask you to calculate pool variance. Again, if you look at the formula for pool variance as you did it before, so here is your pool variance formula. Sorry, here is the pool variance. You can calculate it. So SF pool is your N1 minus 1 times the SF1 square, your variance, times the variance N2 minus 1 times variance 2 divided by N1 plus N2 minus 2. So you use that and then calculate T statistics. Again, this example in your handout, page 24, page 24 and 5 tell you what you need to do for in terms of hypothesis for this problem. Problem 6, basically we have a situation baseline and before and after situation, A1C, and for 10 patient, what kind of a statistics you're going to use. Remember, these are dependent and they are sort of match. I ask you to calculate T statistic and then do hypothesis. So if you look at your handout again, here, when you have the example in page 29, your handout, basically I tell you how to calculate your T statistics and do the hypothesis, basically using that page 29 and 30 of your handout help you. So question 7, we have a new treatment to quit smoking for adults. 70 of 100 subjects who received the standard treatment respond favorably. Of 100 subjects who received the new treatment, 8 responded favorably. So here I ask you what kind of, remember, here we are talking about proportion and you have 2 samples, what the statistical test you use, and then calculate the statistics and then conclude, make your conclusion. So again, you did the confidence interval for 1 and 2 sample proportion. Now you're going to use here the example in page 38 of your handout, show you what you need to do to calculate the Z statistic and make conclusion in terms of hypothesis testing. One thing you want to make sure if your test is 1 side or 2 side, because there is a keyword you want to make sure if it's directional, you consider as 1 side. So those pages help you to understand what you need to do for this problem. Question 8, we have a simple random sample of 20 patients who participate on level of anxiety. The variance of sample for test was 1600. So we wanted to know if we can conclude from data this variance is different from 2000. So remember, this is the testing the population variance. So when you have one sample, you use the chi-square test. You put the sample information divided by multiple by n times minus 1, and then divided by the hypothesis. And so if your hypothesis is greater, then you're using this chi-square from chi-square n minus 1 1 alpha. If it's less than, then this is the chi-square from table. If it's both sides, then you're going to use this, find the critical value from table from these two information from the two terms here. So make sure you understand is one-sided or two-sided. The example in page 39, your handout, it shows we had two-sided. So, and we find both of chi-square value from table, and then 6.86 was greater than 5. So we failed to reject it. So it should be less than 5.6. But your assignment, you want to make sure if it's one side or two-sided. So here I ask you, it's different. So if it's two-sided, you do the same way I did it in example. Find those two values. If your test is not meeting with one of those, then you reject it the same way. If it's sort of, you want to say if your test statistics less than this or greater than that. If it's not, if it is, then you reject a null. If it's not, you fail to reject. So make sure you understand that. Question 9 is basically, now we have two sample variants, and we wanted to test that. So again, if you look at your handout, for two sample, basically the statistic is simple. Sample 1 variance divided by 2 give you the F statistic. Now, for one side, you have to look at F table, and if it's greater, you use F, your statistic greater than Fn1 minus 1. That's your numerator, that's your denominator, 1 minus alpha. However, if it's less than, then you have to convert these basically to 1 over Fn2 minus 1 or N1 minus 1 and find it. If you look at the example I have, basically help you to understand. So here our hypothesis was greater. So 0.95, 21, and 14 was 2.39. And then our statistics was 1.31. So we failed to reject the null. So you want to do the same here. Again, we would like to know if these sufficient anxiety if you make greater. So make sure you understand if it's one side or two side. Question 10, I asked for you to look at the factor related to satisfaction, and in table 1, what are the mean and confidence interval for labor pain? So so you find in table 1 here and find your so this is your table 1. So this is your labor pain, and so labor pain, and what is the confidence interval for that table, and what is the mean and confidence for overall global satisfaction, and what is the confidence interval total childbirth satisfaction by education. So basically for the last one, you're going to look at table 2. So you have education here, looking at the education, high school and college, and find the confidence interval. For question 11, again, you're looking at a related factor related to a smoking in college. What statistical test we use in table 2? What is the p-value? What